Hello, everybody, and welcome to Tuesday. We're continuing in our ever ongoing unit about functions, which involves modeling and predicting change. And the most recent way that we've learned to model and predict change is using scatter plots and lines of best fit, which we realize that in real life, points of data don't always lie on a straight line. So that's what a scatter plot is used for, is to investigate the relationship of two quantities of data. And then once we have that information plotted, we can draw what we call the line of best fit if the scatter plot has a linear pattern. And we can use the line to summarize the data and predict data that's not represented on the graph. And we can do that by simply reading the line, or we can do that by using the equation of the line of best fit, which is computed using the Desmos calculator. Okay? So we next learned, as we had already known, that we have strong and weak positive correlations and strong and weak negative correlations. But we realized we could determine how closely aligned the data is by computing what we call the correlation coefficient, which is the R value. And so we have the Desmos calculator to do that for us. And then we simply took the R value, or the correlation coefficient, to answer the question, how closely aligned is the data? And we simply apply it to the scale down below. Okay, so what we're going to look at today is we're going to try to answer the question, is the linear model the best fit? And what we mean by this is when you look at a set of data and we use our Desmos calculator to find the line of best fit for the scatter plot, is a linear model or a linear function always going to be the best way to represent the relationship of two sets of data? So what we have to help us determine this is what we call the residual. And the residual is a measurement. It's a statistical measurement, and it simply means the vertical distance between a point and the line of best fit. So here is a point, and this red line here is the distance from the point to the line of best fit. All right, on these 4 points, I went ahead and drew one in for you. And this is what we call the residual. And the residual is what tells us if the linear model is the best way to model a set of data. So it's another measurement, and it's simply a measurement of distance. All right, so what we're going to do is we're going to use this measurement to determine if the model is truly something that can be represented by a linear function, or if we should look at a different function to do that. So it's really pretty easy to do. The first thing we're going to do is calculate the line of best fit. Then we're going to use the line of best fit to find the predicted values, and we're going to do that by substituting x. And then we're going to subtract the predicted from the actual to find the residual. Okay, so my actual values, which are over here, my actual x and actual y values, these are the actual values that are on your graph, okay, from the previous, or what would be something similar to the previous example. Okay, so here's how we do this. And we know if we're trying to find the line of best fit, we're going to use our Desmos graphing calculator. So let's come over here and we will insert the table. All right, so there we have our points. And then now we simply come down here and we enter y1 is approximately mx1 plus b. Okay, and so that gives us the equation for the line of best fit. So as you see down here, m equals 2 and y equals a negative 0.5. So that means the equation for my line of best fit is going to be y equals 2x minus 0.5 or 0.5. Okay, so what I'm going to do is take that equation and I'm going to come over here, and like we had said, we are going to use our predicted value and our actual value to find the residual. So if I take the equation for the line of best fit, which is going to be the y equals 2x minus 0.5. Okay, and what I'm going to do is start with the first one here, which is 1. So I have 2 times 1 minus 0.5. So that's going to be y equals 1.5. So my predicted value here for the value of 1 would be 1.5. Now my next one is 2. Oops, wrong font. Is 2. So I'm going to have y equals 2 times 2 minus 0.5. So 2 times 2 is 4 minus 0.5. So y equals 3.5. So I predict 3.5. So then I have here 3. All right, so my predicted value here is 5.5. And then we'll do 4. All right, so here we have 7.5. All right, so those are all my predicted values for my various x inputs based upon the equation for my line of best fit. Now, to find the residual, I'm going to subtract the predicted value from the actual value. So when I do that, my first predicted value is going to be 1.5. So I'm going to subtract that from the actual value. Okay, so my predicted value is 1.5. My actual value is 2. So 2 minus 1.5 gives me a residual of 0.5. And then here, my 3 minus 3.5 gives me a residual of a negative 0.5. Then I have 5 minus 5.5, which gives me another residual of a negative 0.5. And then I have 8 minus 7.5, which gives me a residual of 0.5 again. All right, so those would be my residuals for this particular problem. Okay, now when I go back here to my slides, all right, so I did my predicted values on the board and then I had my residual values. So now we need to ask the question, is the linear model a good fit? Well, what we have here is an extra table of data, but the way we're really going to know if it's a model that is a good fit is we're going to need to graph these residuals on our graph as well. So what we have here in Desmos, and some of you may have noticed this already, is the word residuals, and you see here the word plot. So if you hit the plot button, it goes ahead and plots all of those points on the graph for you. Okay, so if you look at it, everything that we just computed on our sheet over here, in this case, is the same thing that Desmos computed, and Desmos graphed it to us. So what does this graph here mean? Does this graph mean it's a good fit or if it's not a good fit? Well, if you notice, this particular residual plot is kind of going in a curve, okay? It starts high, goes low, and goes high again. So since it's more of a curve versus a type of a linear function, we're going to say, is this model a good fit? We would type the answer over here, no, because it is like a curve. Okay, so because it's kind of in a curve shape, it is not a good fit. All right, now if you look at our next example, okay, our next example here, is there an easier way? And so we see here the table below shows the lengths and corresponding weights of yellowfin tuna. Determine if the linear model is a good fit. Well, there is a much easier way than making one of these tables every single time. And the easier way, like I just showed you, is to use the Desmos graphing calculator. Okay, so here's what we'll do for this one: is go ahead and let's clear our calculator. Now let's start again with the data for this yellowfin tuna. Okay, so we have the length of the tuna and we have the weight of the tuna. So I'll go ahead and type those numbers in here, and you can feel free to type them in with me at home. All right, so here's what it looks like. Okay, now again, what is it that we want to do? We want to plot the residuals, because if we allow Desmos to plot the residuals for us, Desmos will do all of this math right here for you, and at the same time, it will give you a plot that you can use. Okay, so let's come down here and we'll do y1 is approximately mx1 plus b. And notice here how, again, we get the R factors, the correlation coefficient, our slope, our y-intercept. Then if I plot, over here, Desmos does all the math for me. And then right down here on my x-axis, I see that I'm given what we call the residuals. Okay, this is the residual plot. So if I zoom into this residual plot, notice how the pattern is different from the previous one that we saw. This pattern is more tightly grouped together around the x-axis. So when you get a pattern like this that is tightly grouped around the x-axis, this type of a pattern is a good fit. So what this tells us is that the linear model is a good fit. So what we'll just do is I'll just insert another text box and say, yes, this is a good fit because the residual plot is close together. Okay? So when you see a residual plot that looks something like this, that means that that linear model is a good fit of your data. So we should use a linear model for that particular data set. All right. So let's look at one last one, which says the owner of a local restaurant selected a random sample of dinner tables at his restaurant. For each table, the owner recorded the total number of people at the table and the dinner bill. Create a scatter plot and line of best fit, then determine if it is a good model using the residual plot. Okay, so this particular example is what the rest of your problems are going to look like for today, how they're going to be worded, and what I'm looking for. So when I show you how to do this one, this is how you should turn in your assignment today. All right, so let's go back to Desmos and let's just reset everything. And we'll insert our table again. So I've got 1, 2, 2, 3, 3, 4, 5, 8, and 10. All right, so that's the number of guests or people that he served at each meal. And then here's the cost of each meal. So one was $8.50, one was $36, one was $32.55, One was $29.30. One was $50.65. Another is $48.75. 63.75, 60, 82.50, and then and then 125.75. All right, so then I'll just come right down here to the next cell, and Y1 is approximately MX1 plus B. All right, so there again, there's my correlation coefficients. There's my slope or my rate of change. Here's my y-intercept. All right, and there's my graph over here. Okay, so now I will hit plot and plot my residuals. All right, so notice kind of what sort of a pattern we have here. Okay, and this particular pattern, while it is kind of all over the place, all right, this tells you that you have a weak linear pattern. But because it sort of shows here this randomness and large amounts of variance from your x-axis, we can still use a linear model in this situation. But what this tells us, what the residuals tell us, is there's a lot of variance between the different points. And so I think if you look at the data yourself, you can see that you have 3 people who had a $29.30 bill, and then 3 people that had a $50.65 bill. So you can kind of see that variance just in the table itself, but this graph gives you a picture of the variance. So what you would conclude here is that yes, you can still use a linear model because the points don't necessarily make a curve, but there's a lot of variance in your data. Okay, so that's what you could conclude there. All right, so all you would need to do then is we'll just screenshot this, right, like so. Grab your data table and a picture there. All right, put it right there. And then you would just insert a text box with a short description and say, yes, this is a good model with a lot of variance. All right, so again, so you're not confused on the previous one because it made a curve, okay? When it makes a curve, it's not a good model. But when you see that it makes something that was tight like we had in our previous model, and one like this that shows you a lot of variance, then you know that would be a good model that you could use, okay? So what you have for the rest of the day is just 4 of these to do on your own, just because I'm pretty confident that you know how to use the Desmos graphing feature. And you can, if I haven't already mentioned it to you, you can use Desmos on your end of course test. So we will spend a lot of time in the rest of the year getting you really comfortable with this program, which I think most of you are right now, so you can use it on your end of course test. But what you're going to do for the next 4 of these is simply go to Desmos, type in the table, see what kind of a residual plot that you get, cut and paste that residual plot onto the slide, and then put in a short explanation about, yes, it is a good model, or if it's a model that makes a curve, then no, it is not a good model. All right, so if you have any questions, I will certainly be on Google Meet today, and I wish you all the best. Have a great day.